So as Sarah said, I'm Elijah. I'm going to be talking about git-filter-repo today. Has anyone used git-filter-repo? Raise hands. Okay, a bunch of you. Although I released it, I think it was about 5.5 years ago now, I've never actually given a talk on it. So today I want to talk a little bit about an overview of what it is and also how I came about, what motivated me to write this. So a little bit, starting high-level overview of what it can be used for. Git-filter-repo is used for rewriting history, has a lot of different capabilities associated with it. A few examples of things it can be used for are restructuring the file layout in history. This might mean, for example, keeping only a subset of your files, or just deleting a small subset of your files, or perhaps renaming things throughout all of history. It might also be used, for example, to modify file contents throughout history, or maybe the commit messages. And there's a number of other things it can do as well. It tries to handle a lot of small concerns to make it feel nice and integrated. So one thing that this includes is, for example, if your Git project refers to previous commits in its commit message, referring to them by hash, when you rewrite history, you're going to get new hashes for all your commits. So it's nice to also update the commit messages automatically to refer to the new commit IDs. So it does that. Another, if you're picking to select only a small subset of your files, a lot of your commits become irrelevant, and it's nice to have those pruned out automatically. It'll also make replace refs and graphs permanent. It will rewrite stashes. Got a little asterisk on that because although that is in the code, it's not in part of any release yet, so that's coming soon. And it also will automatically clean out the old history and repack things. A few important points to keep in mind about git-filter-repo if you go to use it. By design, it's destructive. The point is getting rid of the old history so you just have the new history. But it does do a check. It encourages you to make a fresh clone before you go do your rewrite in case you make a mistake. And it'll check to see if it looks like you're in a fresh clone or not, and abort by default if you're not. It strips out any extended commit headers, such as commit signatures or Git butler change IDs or anything you guys are about to add because of what Scott just encouraged you to be able to do. At least that's what it currently does because fast export and fast import strips those out. You can do filtering via 2 or more invocations of git-filter-repo. Some people get stuck on thinking they need to do it all in one. If it's easier to split it up into multiple steps, that's fine. And there's a couple of use cases that people keep on asking about, so I just want to cover that they're not part of what git-filter-repo does. One is people want to filter out a small portion of their repository, have it rewritten into another separate one, do some development on it, and then bring all the changes back and then keep on doing bidirectional development between these 2 repositories. There is a project that does do that called Josh Project. It was covered at GitMerge 2020 if I remember correctly. They have a much more limited way of things, what you're allowed to do in terms of rewriting, because they're focused really strongly on this bidirectional incremental development between the 2 versions. Whereas git-filter-repo focuses on trying to make it as flexible as possible for the kinds of rewrites that you can do. Another is skipping the changes made by one specific commit isn't supported. If you want to do something like that, that's really a rebase-like operation. And if you're going to do that, when you skip the changes to commit, you might run into conflicts, so you're going to have to be prepared for that. Some things probably ought to go without saying, but keep on coming up in terms of people filing issues. This isn't something to be used lightly. When you rewrite history, all the commit IDs are going to change. So that's a big thing. And another is, if you're going to run a command that has --force in it, and you don't read any part of the manual whatsoever, the --force tells it don't do that fresh clone check to save you. And so if you don't have a backup of your code, you're going to have a rough day or a rough week. So now I wanted to go a little bit into some of the use cases that led me to developing this tool. So there were 3 major use cases that really led me to it. First of all, a couple companies ago, Sandia National Labs, it was like 15 years ago, they were converting from CVS to Git. And instead of using CVS workflows inside Git, we wanted to really use Git workflows. And so I wanted to do some modifications to the repository around that. Another one that came up at one company ago, Palantir, that I worked at, was splitting out a portion of the current repository for joining into some larger monorepo. And a third use case was trying to remove some really large clutter that had been committed back when people were new to Git, and made all of our fetches slow for a decade afterwards. So starting off with the first of those use cases, when we're switching from CVS to Git, one of the things they had, there was these things called CVS keywords, and they were in all the source files. And it's because CVS was so slow that running CVS status, people just wouldn't do it. And Git status was more or less instantaneous. So I just wanted to strip all of those out. And I didn't have a good repository example to be able to rerun this to see how slow it was, but the idea was it had to touch most of the files, and so I picked another humorous example for modifying all files in a repository. Let's say you wanted to reformat all of 1.7 million commits of Linux to use LLVM coding style instead of kernel coding style. Not sure you'd really want to do this, but just for fun. So this is what the tool at the time that existed, git-filter-branch, how you would run it to do this kind of thing. Can add a little bit of safety that often gets overlooked with the flags, and there's also a performance hack, at least on Linux, for how you could speed this up a little bit. But even with that performance hack, I didn't have enough patience to wait for it to finish. It would be somewhere around a decade to be able to run. And the reason for that is if you had some kind of file that was in the early part of Linux's history, and it only was changed 5 times, you would still need to rewrite it 1.7 million times. And so what we would really want instead is something that would operate on just the number of times each file changed and just making changes to those. So by contrast, if you use lint history is a little demo example I have that's built on top of filter-repo. I made a whole bunch of examples of how you can write new history writing tools using git-filter-repo as a library. So doing the equivalent thing with it, you run this, and it only takes a little over a day. Okay, so you get a much different thing, but it's because it was based on different tooling. So instead of checking out every version and working on all the files that are in it, regardless of whether they changed relative to the last version, it worked on the get fast export stream, reading that into some Python data structures that you can then operate on, and then sending it back out to get fast import. And I made this into a little library at the time called Get Fast Filter. Didn't actually get picked up a lot. I think in part because it was too much overhead to get started, especially for the small rewrites. But a number of years later, move on to the next use case. So my previous employer, Palantir, was kind of split-brained at times about did they want to have just a few big monorepos, or did they want to have thousands of small repositories, and they orchestrated them together. And because they kept on switching back and forth what they wanted, a use case that just kept on coming up over there was, they wanted to extract perhaps just the back-end code from some repository and merge it into the big back-end monorepo. But even that example is a little bit too complex to start with, so I wanted to do something simpler. Also on the amusing side, let's say that we go back to the Linux repository again, and I want to rename the drivers directory to pilots. If we were to do this with git-filter-branch, tool that really existed at the time to be able to do that, you'd probably come up with a command that looked something like this. It wouldn't work. There's a little bug there, easy enough to fix up. Another little bug you got to fix up. And then put that performance hack back in. And all we're really doing is renaming a directory throughout all these commits. But it still took months. Or that's the approximation because I didn't have enough time to wait for it. So I had to estimate. But some people will notice that this uses tree filter. If you've used git-filter-branch before, there's also a thing called index filter. This is a particular use case that can make use of that, and that's faster. The command gets a little bit more complicated, also more error prone, but you can fix that up. But that still takes the order of days. Whereas when I made a little command to do this within git-filter-repo, operating on the fast export, fast import stream. This drops down to just minutes to be able to do this rewrite. And now moving to the slightly more complicated example. So those things so far gave us the performance look. Now I'm going to focus a little bit more on just the usability. So this was the simplest form of that common use case that I had, where we want to extract some small subset of the history. For example, in this case, we'll just take the source subdirectory, getting rid of everything else from your repository, then renaming everything to have a new leading directory, my module in this case. And then because we want to merge this smaller history into a bigger monorepo, we don't want the tags to conflict. So we want to rename all the tags. If we were to use git-filter-branch for this, the commands that you'd come up with look something like this, that you come up with over time. And I've mentioned safety before. There's also safety issues here that have to get fixed up, often overlooked, and you'll corrupt your rewrite if you don't get some of these, depending on the shape of your repository. There's also, the second command down there was to get rid of all the old objects, as suggested by the git-filter-branch manual. Wasn't enough steps, though. You actually had to do more than what the manual said to actually get rid of the old objects. But this was the really simplest form of some of the rewrites we wanted to do. It ended up being somewhat difficult to get it all written and debugged. And since it would take forever to run, I usually didn't get a second chance to go back and get it all fixed up. With git-filter-repo, it's a lot simpler. You can almost read from the command line what kinds of things I'm trying to do. I want to select out just the source directory to keep. I want to move this all into a subdirectory called my module, and I want to rename my tags to have a new my module prefix. But one question that you might be asking yourself is, okay, but there were other tools at the time, why didn't I just improve those tools? Starting out with git-filter-branch, it's really slow. Using it is kind of like waiting for your birth certificate to expire. And its performance woes weren't something that were just an implementation bug that could be fixed. It was built into its design. And the safety problems were actually even worse. And its own manual says so. I won't read through it all, but there are a long list of things that I added to its manual to explain to people why it couldn't be fixed that are in here. There was another tool that came after git-fast-filter that I created, but before I turned that into git-filter-repo, BFG repo cleaner. It's a great tool. It's really quick. It has some really nice design ideas, but it only solves a few use cases, and in fact, none of the main ones that I had, and couldn't really be extended to handle those use cases. It had one big fundamental shortcoming. Its whole design was based around walking through packs and packed refs files, and that meant a few things. One, it only provided an ability to work on base names. So you could tell it instructions relative to, say, README, and that'd be all the README files within your repository. You couldn't specify a particular one. And that meant that no file restructurings were really possible with it. All it can be used to do is delete a few files by name. And all of my use cases had restructuring workflows within them. But it had some other knock-on effects as well. It couldn't rewrite history if you had loose objects or loose refs. And you might say, well, just repack beforehand. In fact, BFG encourages you to do that. Please make sure you repack before you use it. But that might not solve everything because of things like core.bigFile threshold. Also, since it only works on packs and packed refs, it doesn't update the working tree or index at the end of the rewrite, which has a number of interesting knock-on usability effects and decisions that they had to make, which make it difficult to extend to other use cases. But as I mentioned before, earlier on the slide, I stole from it liberally because it does solve two use cases really nicely and has a number of flags for those use cases. And so I basically just copied the same flags, implemented them in git-filter-repo, and they mostly have the same meaning. One big difference is that when you specify paths to git-filter-repo, it assumes that those are the paths you want to keep, and you're excluding everything else. Whereas BFG Repo Cleaner only has the option to delete things by path. So that's why the existing tools just couldn't be extended to do the things that I wanted. But I also mentioned earlier that I had a third use case, excising some really large historical cruft. Unfortunately, tools at the time for trying to find what the large cruft was, I thought weren't all that great. A lot of the guides, there were some that existed, but they all presupposed that the problem was a few individual big blobs. And while that was certainly a problem in our case, the individual big blobs only accounted for part of my estimate for what the unnecessary bloat was. There were too many files to look through and try to find all of them. And by trying to find them just by individual files, I couldn't really get them. But if I looked at the problem a little bit differently, I was able to find it. So not only just individual blobs, but if I accumulated sizes by extension or by directory, I was able to find more. In particular, this repository that I was really dealing with had the few really large blobs that it had were demos, tarballs of all the files that were involved in some kind of demo. And they had a few versions of it because over time they updated the demo and then they checked in a new tarball. It was just huge. But they also had an untarred version of it at some point in history with various changes. And the individual files weren't big enough to make things really large, but the combination of all of them were. And so if I was able to look at it by directory, I would see it and say, oh, I want to get rid of that directory instead of just certain files within it. So I actually built this into git-filter-repo with an analyze flag. This particular flag doesn't make any changes to your repository. All it does is provide you with some information about it. When you run it, it creates a bunch of files afterwards that basically has the accumulations of sizes by path, by extension, and by directory. So they would look, for example, like this. You run on your repository, you look at this path all size afterwards, and it has the accumulated both unpacked and packed sizes for that particular path name, as well as whether that file was deleted at some point in the past. Because sometimes that was a good hint that, people didn't want it, or it's been so long we can't even build that old of a version anyway. So it'd be okay to extract and get out of the repo at this point. And then there's the other files are almost identical. They're just accumulated by extension or by directory. And by using the combination of those things, I was able to reduce a repository size by a factor of 5, whereas if I had just done the few big individual blogs, it would have only been a factor of 2. So those were the use cases that led me to develop this, but I also wanted to cover a few other use cases that git-filter-repo can be used for. I mentioned restructuring workflows. There's a number of other restructurings you can do as well. For example, if you want to remove just a few paths, that -- invert paths is because what I said before, the default is -- path specifies what to include. So -- invert path says, no, these are actually the things I'm specifying to delete and get rid of. Instead of just mentioning them by path, you can also use a glob. There's also a regex capability, a -- path regex. Sometimes you have a really long list of files that you want to either include or a list of files you want to delete, so you can stick them inside some kind of file. And this -- paths from file actually has is fairly versatile itself. You can actually use things within it to specify what you want to keep by glob, by regex, if you want to do renames. So it allows you to do all kinds of different restructurings. And if that's not flexible enough for you, we allow you to specify things by code. So there's a file name callback, and you can just specify actual Python that it'll compile into a function and use as it's doing the rewrite. So for example, if you want to remove all file names with backslashes, just write this simple little command on the command line that includes some Python code, and it says, okay, I'll delete the files that have a backslash in it. Another one related to what Patrick talked about, where Mac is a little bit weird and it does UTF-8 normalization for all of its files. People have asked for, is there a way to go and rewrite all the file names in history to use the new Mac renormalization instead of the old one, NFD versus NFC. And there's a little icon V command that does this conversion for you, and so you can just use it. Except that if you have a file that's not valid UTF-8, it'll throw an error, so add a little try except around it and say, I'll just return the original file name in that case. Because of time, I'm gonna have to skip this slide, but there's a lot of things you can do with git replace as well. Git-filter-repo also allows you to replace text in non-binary files found throughout the repository. It has some language, and this was actually copied from BFG repo cleaner. Very similar thing. So you can be able to say, hey, I want to be able to get rid of anywhere that has this password in all my files. And it'll, since there was no replacement specified for that on the first line, it just has a default replacement of asterisk surround replaced. But you can specify the replacement as well as some of these other lines do. And you can use globs and regexes as well when you're doing the replacement. And in addition to being able to replace the contents of files throughout history, there's a very similar command for replacing commit messages throughout history using a file with the same kind of structure. And there's a lot of other flags. I've only kind of scratched the surface here. But in addition to all the flags that you can use at the command line, git-filter-repo can also be used as a library that you import and then write a completely new filtering program. The lint history example I gave near the beginning is one such example. And I wanted to show what kinds of ranges of different things you could do with it. And so I've picked the two most diametrically different tools I could think of that were in this space, git-filter-branch and BFG, and wrote complete versions of them on top of git-filter-repo. So there's examples of very different things you can be able to do with it. And I just wanted to end with, I hope you rarely ever need to use history rewriting tools. These aren't meant to be used all the time, but it does come up. I saw several hands, and if it comes up for you, I hope that git-filter-repo comes in very handy for you. Thank you.